Hi guys, welcome back to the system design interview preparation videos. Today we are going to go through some general considerations like common component service in a typical system design interview setup. One thing I want to point out, it is important to come out with a thinking framework during the system design interviews or in your day-to-day how to solve a problem, especially when it comes to technical decisions or solutions. I'll share like what works best for me for up until now. So I consider things into three categories: time, space, cost across compute, storage, and network. So that's normally what works best for me. So time is about like latency, it's about buffer on the client side, it's about like transaction, the cost and the processing time, parallel response time, latency, availability, those type of considerations. For space, of course, it's about a different type of storage, how efficient they are, like for different scenarios, like memory footprint as well, caching efficiency, SQL, NoSQL, object storage, partition replication that comes with that. That's my thinking process. And also on the cost, it's about the infrastructure, operation, maintenance, third party, or build our own open source or off the shelf directly about data transfer, data storage, computing cost. I'll be also licensing, like cost per API for third party. So those are the consideration areas. So it is indeed important to build like your thinking framework. So that would be applicable to any given scenario to help you navigate through the problem and identify the best solution possible. And for compute, storage, and network, compute is all these are self-explanatory. Like compute is about CPU, memory usage, concurrency, parallelism, auto scaling, efficiency of the algorithm. Storage, again, it's disk, memory, like caching trade-off, indexing, partitioning, eventual strong consistency. For network, it's about bandwidth, about routing, but distributing the workload evenly or most efficiently using of like CDNs and caching on the client side, different layers at load balancing level, gateway level, service level, and also use like message queues as override, but it solves the problems, and also event streaming platform and latency optimization. So that's what works best for me. So let's just walk through some general design concept without like any given topic, but let's try to think from the user perspective. Let's just say 20 million monthly active users for any given system. So we'll see where it leaves us. So normally that would be a starting point where the actions or date initialized. Let's say it from client side, we will kind of pipe or wipe to most popular starting point if it's blind initiated. And then at this scale, you would think about you have load balancing upfront to distribute the traffic. So the consideration here, if it's really large scale, if it's globally data centers, you need to have like global server load balancing. This is top layer of load balancing, which will direct traffic to your local load balancing. By local, I didn't mean like on your local machine. It might be local data center or even availability zone. So you can see even for at large scale, even for load balancing is tiered. And depends on your traffic, it will also be making sense to have like hot standby load balancing or master or active. So as you can imagine, it's adding complexity based on the volume. So the point is like don't over engineering if you don't need that. Maybe at Google and the Meta level, you will need active global server load balancing, but for smaller scales, a master, slave, or active hot standby would be sufficient enough. And also load balancing I don't believe it will go into really details, but from the OSI 7-layer perspective, well, we can have like the load balancing at lower 3 or lower 4, that's based on like the 5 tuples. A source, dest, port, IP address, etc. A MAC address, it will have like it's for super efficiency. And then for lower 7, you will have like more information, like user information or application level information. You can do load balancing based on those information. So normally for global server might be on level 7, layer 4, like transport or network. And for data center level, it can be either or both, it can only be layer 7 or layer 4, layer 7. This depends on the special use case and how the traffic pattern. And after this, that would be API gateway layer. That's the entry point to your backend service. And also for load balancing and the network part, maybe and the data center, from data center perspective, there will be like multiple suppliers on the network. You have like the main or backup or just two running at the same time. That will reduce the possibility of any network errors provided by any one provider. And API gateway layer, it's a like entry point. It can handle some generic tasks like throttling, tracing, SSL termination. It can also have like blacklist, whitelist, or cached response. So it's quite powerful. I will do a deep dive into API gateway layer at some point. And also, as always, it could be multiple instances running as well to serve the purpose. Then next one, it would be the actual service endpoint, say service 1. And given the scale, normally it's a good practice to make sure these services are stateless, which means each server or each service request, we don't have the information about the session. So that means we need to have like a distributed session management. Some common choice here would be like Redis, DynamoDB, or even Cassandra for their great handling of high throughput. And for stateless service, the concept, inevitably, we need to talk about like auto scaling. Of course, if you are in a cloud environment, it will be easy to set up. For example, in Amazon, you can do with their load balancing and also like set up like an auto scaling group, certain rules, or you are running your own infrastructure. Probably you can use Kubernetes, Docker, Swarm, etc. That would be tons of options to do it here. So, but you need to mention about like auto scaling, and also the configurations based on traffic. I think that's the important thing. So you are aware of the concept, both for serving the customer when the load increases, and also from cost efficiency and the maintenance perspective, you can reduce the number of service instance when there's a low traffic volume. And also another main concept would be like service discovery. And the registration. Because in a distributed and auto-scaling group, the services or service instance can go up and down at any given time. It is important when the service is running up, it registers itself from the central registry, and then so other services or the API gateway or load balancing can discover those services. I will certainly create a separate topic for that. Some common tools like Consul, Zookeeper, etc. is designed to manage all this, and also for the access strategies, that's two part. We can access directly from the client side. Client side make a request to the service registry, and then request, hey, what is the service one located or service two located? And then it will get the IP or naming, and then it will call them directly, or it will come through load balancing or API gateway again. But API gateway will calling the service registry to know where exactly to pass on the request. So let's see. And then some main concept here. Once the request hits the server, it will be caching event streaming. Message queues. So after the request comes to the server, it can either read from the cache or write to the cache. That's for faster response or like faster storage and retrieval. And for event streaming, that would be like you publish a topic, for example, in the Kafka case. And then downstream, we can have like multiple consumers to consume the event. It could be in different domain. It could be different steps to handle that in parallel. So you can see it's decouple of the concerns, and you can scaling each part separately. And also like it's written once, consumed multiple times. It can like improve the parallelism. And so message queues uh, have similar purpose. Once you have the request put in the message queue, you can have like a workers or a consumers to read from the queue, so you don't get like overloaded. And also you can scale up a request. So some major concept here is about you have workers, consumers group to consume the events or queuing items. And then at the last is about like storage. Oops. This would be the design considerations about like SQL, NoSQL, like object storage, most popular ones, topics. There will be also block storage and file storage, but I think this less common in the system design interview. But you want to look into details, there are tons of material for that. And for SQL, of course, there will be topics of like partition, sharding, replication to improve availability, reliability, etc. NoSQL is most popular for their high throughput handling, like horizontal scalable by default. And for object storage, of course, it's good for store like a blob or large video, audio files. And then also maybe go back to the client side. There'll be main concept about like DNS is where they are finding the IP address for the service they need to connect to. And also on the caching side, popular concept about like a CDN. I can have cache static, high frequently accessed content close to the client, geographically to reduce latency and to achieve like fast response. I think that's pretty much the structure you need to have in the system design interview. And of course, if we go deeper into each step, there'll be like multiple topics we can cover. For example, like caching set, about the caching strategies, time to live, least recently used or least frequently used. Or for any date, we can have like a checksum, like a sequence number to ensure integrity. And also there will be like replication policies, like the consensus. Um, we can have like deep dive into these topics. Also, yeah, we can have like other concept I can list in the different video of like a Bloom filter, which like for fast uh, making fast decisions if the possibility if the data exists in the server or not. And also, as always, it's worth mentioning about like observability or monitoring for the system. So you know the system health based on date, so you can fine tune any given part of the system. All right, let me know if it's helpful, and also if you want to deep dive into any of the topics, please let me know. All right, guys, have a good time preparing your upcoming interviews, and let me know if you like tailored coaching or feedback or just a dry run before your upcoming interviews. Thank you. See you next time.